In lesson 4.3, we're going to take a look at direct variation. Now, direct variation means that y varies directly as x, and we use this formula y is equal to kx, and k is a constant variation. So you guys are going to start to see this pattern, and we're going to try to determine if x and y are proportionate to each other. So let's look at this first example. We need to start with this original equation, y is equal to k times x, and you need to plug in what you have. So let's take one y value and one x value. So y is 12, okay, x is 6, but we really should put it in front of the variable that we're solving for. So 12 is equal to 6 times k. Now this is a one-step equation. You're going to divide both sides by 6, and 2 is equal to k. So that's your constant of variation. That basically means, if you go back to your original equation, if k is 2, this is your line. Y is equal to 2 times x. So whatever x is, this is your rule, okay? You multiply it by 2 and you get your y. So 7 times 2 is 14. 8 times 2 is 16. If we had 9 for x, your y would be 18. And these are all proportionate to each other, all right? That's your rule. So let's look at another example. With different values, y is equal to k times x. Y here is 30. And x is 10, so we're going to say 10 times k. Now you solve it, divide both sides by 10, this is a one-step equation. 30 divided by 10 is 3, and that's your constant of variation. So now your line is going to be y is equal to, just fill in the k, 3 times x, all right? And that's your line, that's your rule. So whatever x is, you multiply it by 3, and you should get y. So 10 times 3 is 30, 5 times 3 is 15, 3 times 3 is 9. Okay, if x was 1, y would be 3. So you can fill in all your missing values. Now, if you have the equation and you're able to find the constant of variation, if there's a missing value, like there's a missing x in this equation, you're able to solve. So we're going to start with this y is equal to k times x. And let's plug in what we have. Y is 28, x is 7, and we need to find the constant of variation. Again, one-step equation, divide both sides by 7. 4 is equal to k, your constant of variation. And the equation is going to be y is equal to 4 times x. So whatever x is, you multiply it by 4 to get your y. All right, so in this case, we need to find the x. So we have a y here. Let's plug in the 52. Plug in what we have. It's equal to 4 times x. So in order to solve for x, divide both sides by 4. 13 is equal to x. So if you're missing variables, if you have the constant variation, you can figure out what your missing variables are. In this example, we're going to be looking for the y. So we're going to use this formula, y is equal to k times x. All right, y is 3, and x is 9. Now, because x is bigger than y, you're going to be left with a fraction. 3/9, which would be reduced to 1/3, is equal to your constant of variation. So your rule or your line here is y is equal to 1/3 times x. So whatever x is, you multiply it by 1/3. So in this case, we're looking for the y. We don't know what it is, but we have the x. So we're going to multiply it by, put the parentheses here, 40.5. 1/3 times 40.5 will give us 13.5. So we're able to figure out what our y value is. All right. Now, if you're just looking at graphs, once you eventually graph this, okay, an easy way to determine what direct variation is if it goes through the origin. So the first example doesn't go through the origin, the second one does. So this is an example of direct variation. The last two examples do not go through the origin. The last one does, but it's not a straight line. So we can eliminate these. If you look at the last example, all right, this graph does not go through the origin, so we're going to say no. This graph does, and so does this graph. This one, again, does not go through the origin. So these two are examples of direct variation. That's pretty much it, guys.